length of muscle before it contracts, what will be the best length for the best performance of the muscle? Or in the other word, to make the greatest isometric active tension. Well, the initial amount of the overlap between actin and myosin determine the tension development by a contracting muscle. There is another parameter also between the length tension relationship is important, is the relating this length and tension development based on the passive elastic act of the titan filament, which happens during the elongation of the muscles. Well, stretching the titan is like stretching a rubber band, which lead to an increasing the passive tension when we increasing the length of the muscle. And as the other parameter I mentioned, the active tension also of a muscle is also can be altered by changing the length of the fiber at the start. At the length in which the fiber develops the greatest isometric active tension, we call it the optimal length, or LO. And also this optimal length for the skeletal muscle is when they are absolutely relaxed. A skeletal muscle is when they are relaxed. As a reference, or the optimal length, we call it the 100% of the muscle length at that optimal length. When it's there, this is 100% of the muscle length. Let's look at this famous graph that you can see in many books and explain it a little bit. Well, in this graph, the vertical axis records the percentage of the maximum isometric tetanic tension, and the other axis is the percent of the muscle length. On the other hand, the sarcomere, we can just use this value also. And as you see, there is a narrow range for the optimal length. It's not just one number, but a very narrow change of the length here. At this range, muscle is relaxed and there is no elongation or contraction. In a normal situation, muscle can increase or decrease the length or to lesser or greater percentage, but it is possible to get out of this physiological range, and if so, we will have a curve like that. And let's see what does it mean, this curve with different parts. The length of sarcomere for the optimal length is about 2 micrometer. After that point of about 70% of the length, as you see, I can show here, up to the 70%. If it's 100%, it reached to 70%. At 70% of the length, then we have a sudden decrease of the tension. And as you see here, at this range, this muscle up to 60%, reach to this 60%, and all the length of the muscle is become so narrow, the Z discs become so narrow, there is no place for more contraction here. And this is the 60% of the optimal length, which will be about 1.60 micrometer, and of the sarcomere length, and so on. There is no space for contraction anymore. But also in the other extreme, if we be able to just stretch the muscle up to about 170% of the optimal length, which is the sarcomere length, become around 2.2 micrometer. The actin filament has pulled all the way out of the end of myosin with no actin-myosin overlap. And at this point, the tension developed by muscle also is 0. If we be able to record the percentage of the developed of the active and passive tensions, then how we can say it? We can say in this coupled graph here. As you see, the maximum tension, developed tension, for developing tension is happening in the optimal length. It's like a bell-shaped curve, but here we only have one parameter, and this is the contractile tension, which is the active tension that we recorded here. However, since the passive tighten, also tension is rising gradually as a curve here, and then as you see, the sum of these two can give us a result of the total tension like this. And as you see, in the normal range we have those parts that we can increase the tension and record it in this way.